You're here with me today in New Mexico where I sit, and we've been running a proof of concept to change the way we consume power and electricity within a data center. We know that about 65% of the power used in a data center is typically mechanical to run the air conditioning units. We try to find a way to radically change that and reduce the amount of energy consumed, which is great from a cost saving but also good for the environment. We found that implementing an air economizer can substantially reduce the data center power consumption and cooling cost, while not jeopardizing server uptime. By using an air economizer 91% of the time, our test shows we can reduce power consumption by about 74% and save up to $2.8 million for a 10 megawatt data center. Air economizers have been around forever in office buildings and data centers and warehouses. Most companies have some percentage of air economizer in their facility. We've taken that to an entirely different level, from 2 to 3% within an office facility to 100% air exchange. An air economizer simply expels the hot air outdoors and draws the outdoor air to cool the IT equipment within the data center, instead of cooling and recirculating the hot air from the servers. Over a 10-month period, we have been running an air economizer test using approximately 900 heavily utilized production servers in a high-density data center. The data center was divided into two sections with an equal number of servers on each side. One side running as a traditional data center with air conditioning, and the other side running the air economizer proof of concept with 100% outside air for cooling. So Intel decided to do the proof of concept at this site in a double-wide construction trailer, quite literally, with 4 50-ton air conditioning units because it was an inexpensive way to prove the theory. This is a very high-end data center with regard to power consumption and CPU utilization. The industry averages, around 10% utilization. We average over 90% in this room. So when you see high density, it's high density at a high usage, which is really different than the industry. So let me take you inside, show you what we're doing, and talk about some of the pros and cons of what we've done. So the traditional side should look about the same. It's the same amount of equipment, the same load of IT power. The difference is it's very clean. It's much cooler in this side. We're on the air economizer side, which is really the proof of concept side. The difference between this side and the traditional side is this air is being sucked out and actually blown outside. We're not cooling any of it. During the experiment, the servers in the economizer side of the data center were subjected to a wide variation of environmental conditions. We actually have 88 sensors in this room, testing humidity and temperature. We need to balance the data, make sure that we don't have any anomalies in the information, so with the data we provide is very accurate. Temperature of the supply air varied from 64 degrees Fahrenheit to more than 92 degrees Fahrenheit. Humidity varied from 4% relative humidity to more than 90%, and changed very rapidly at times. A layer of dust covered the servers and the interior of the compartment. So this is the outside. This is where we exchange the air. So what you can see here is two pieces. This is actually the exhaust air. The air temperature out of the back of a server that we have in there is about 126 degrees Fahrenheit. The hot air is sucked up to the ceiling. It comes across the ductwork and actually just exhausts 100% of the air. On this side, this is actually the inlet side. So 100% of the air that's in the room is sucked up through these inlets into the room and then comes back out the other side once it's heated. When using the economizer, the DX cooling load in the economizer compartment was reduced from over 111 kilowatts to just above 28 kilowatts, representing a 74% energy reduction. Challenging established industry assumptions, there was no significant increase in server failure rate in the economizer compartment, even when subjected to considerable variations in temperature and humidity, as well as poor air quality. So this is just one example of many that we've done in the past and many that we plan to do in the future on changing the way data centers are run and changing the way and the impact we have to the environment as a whole.